Chapter 11, Using Bind Variables. After completing this lesson, you should be able to list the benefits of using bind variables, use bind peaking, use adaptive cursor sharing, and describe some common observations. The first topic in this chapter is about cursor sharing and different literal values. Suppose the following. You have your library cache, which is a part of your shared pool, in which the executed SQL statements are going to be stored alongside with their execution plan. Suppose that you're going to execute a statement select star from jobs where minimum salary is bigger than 12,000. You will try to find an exact match of this statement inside that library cache. If he doesn't find that statement, he will have to do a hard parse, and the optimizer will come up with an execution plan to carry out this select statement where you're looking for a minimum salary bigger than 12,000. Now, once the execution plan has been rendered, the SQL text plus its execution plan will be stored inside that library cache. And then the statement will be executed. If then somebody would execute select star from jobs where minimum salary is bigger than 18,000, he will search first for an exact match in that library cache of that shared pool. Now, he will not find an exact match of that statement if it's being executed for the very first time, because this select statement, due to the literal value 18,000, it's not the same as the previously executed select statement where we were looking for minimum salary bigger than 12,000. So he will need to do a hard parsing and come up with an execution plan. And the SQL text of that second select statement, alongside its execution plan, is going to be stored in the library cache, and then the statement gets executed. If then somebody would execute a third select statement, where that person reads from table jobs where the minimum salary is bigger than 7,500, he will try to find an exact match of that statement inside the library cache of the shared pool. Now, he will not find an exact match of that statement if it's being executed the very first time, because due to the literal value 7,500, it's not the same statement as where you were looking for 18,000 or where you were looking for a minimum salary bigger than 12,000. So he will need to do also a hard parsing, in fact, and then store the SQL text plus its execution plan inside the library cache of the shared pool. So what you have is that here cursors are not being shared for the simple reason that due to different literal values, each statement is almost the same, but it's not exactly the same statement. So you will have extra parse time plus extra memory that is needed in the library cache to store all of that information. Now, what if you would use bind variables? So what's going to happen is the following. Let's say that you perform a select statement from jobs where the minimum salary is bigger than a bind variable, in fact. And a bind variable behaves like a host variable, and you can give, for the duration of your session, you can give a host variable a specific value. So suppose that before you execute this first select statement, you have given the minimum salary bind variable the value of 12,000. Well, what's going to happen is, based upon that value of 12,000, an execution plan will be generated. Once that execution plan is generated, that select statement, that specific SQL text with the bind variable syntax, alongside with its execution plan, will be stored inside the library cache, and then the statement gets executed. Now, suppose now somebody is going to execute this exactly the same statement using bind variable min_cell, but that person has given that bind variable for his session the value of 18,000. Now, what's going to happen is going to see if he can find an exact match of that SQL statement inside the library cache of the shared pool. Now, he will find an exact match because that same statement was already executed before. So he finds an exact match. He has immediately the execution plan, so he can start immediately executing that second select statement but of course keeping in mind that it's looking for a minimum salary bigger than 18,000. If then another session would execute select star from jobs where minimum salary is bigger than min cell bind variable, he will first look for an exact match in the library cache, which he will find. He will pick up the execution plan associated with that select statement, and he will start immediately executing that select statement, bearing in mind that for that session, this select statement is looking for jobs where the minimum salary is bigger than 17,500. Now, by making use of this bind variable, you see that 3 times exactly the same select statement has been executed. Yeah, this means cursor sharing. And cursor sharing means that there is less time spent on parsing, because we avoid hard parsing in fact. Plus you will also need less memory inside the library cache to cache SQL statements and their according execution plan. That is cursor sharing and bind variables. Now here you see an example on how to use bind variables in SQL Plus in fact. But let me show you a demo that I have upon my practice machine. Now what do you see? For instance, look, this is an SQL Plus session where via the SQL Plus command variable I can actually create a bind variable with here bearing the name GA name of the data type varchar2 in fact. And then I'm going to assign this bind variable the value king in fact. And then here I say, look, select salary from employees where last name equals, and I'm referring to my bind variable that I have created and given the value king in my session in fact. And I see that there are 2 salaries returned because apparently there are 2 persons with the last name king stored inside my table employees. But then you see that within my same session, I gave my bind variable now the value de Haan, and I'm looking for the people, or looking for the salaries of the people who have as last name de Haan in fact. But this is exactly the same statement that is being executed, but always when it's executing, keeping in mind what is the current value of that bind variable in the session in fact. So this is how bind variables are allocated, assigned values to, and how they are being referred to in SQL statements. This is what you will find over here on this slide as well. Now, bind variables are session variables, host variables. This is how you allocate and assign values to bind variables in SQL Plus. But here you also have the possibility of specifying bind variables in Oracle SQL Developer. The only thing that you need to do is in your worksheet, you type in your select statement and you type in bind variable names of your own choice. At the moment that you're now going to execute that statement, you will get a pop-up window stating, look, I see that you have 2 bind variables, low cell and high cell. Can you give me the values for those bind variables, for those session variables, low cell and high cell? Can you please provide me their values? And then those values will be used during the execution, in fact. So you can use bind variables in SQL Plus as well as in SQL Developer. Now, the next topic in this chapter is the so-called bind variable peaking. Now, what is bind variable peaking? Well, it's actually easy to explain. Suppose the following. This select statement over here. So select star from jobs where the minimum salary is bigger than a bind variable value, in fact. Let's say that that select statement, it's the very first time that it's going to be executed. This means that if he's looking up in the library cache, if there is an exact match of that select statement, he will not find an exact match of that statement because it's the very first time that you execute it. So he will need to do a hard parsing, and during hard parsing, one of the things that needs to happen is that the optimizer has to come up with an execution plan. Now, whenever the optimizer is going to build up an execution plan, he's going to make estimates on how many records it thinks it's going to retrieve via that select statement, in fact. So he has to calculate selectivity, he needs to calculate cardinality, in fact. Now what will happen is, the very first time that you execute that select statement, the optimizer has to build an execution plan. But in order to calculate that selectivity or cardinality, he's going to have a look, yeah, but what did you set as value for that bind variable? And he sees, for instance, that the session has set the value of that bind variable min_cell to 12,000. So he will peek at that value, which is in this case 12,000, and he will use that value to calculate selectivity, to calculate cardinality, and making an estimate on how many rows it thinks is going to be retrieved, where the minimum salary is bigger than 12,000. And based upon that, he's going to build up an execution plan, and that execution plan, together with the select text, will be stored inside the library cache. Now, the next time this statement gets executed, he will find an exact match in the library cache. He will find immediately the execution plan, and he will use that execution plan to execute that statement. But bearing in mind that for that session, we are now looking for jobs where the minimum salary is bigger than 18,000. He will no longer perform that bind peaking. That's something that is only done at the first execution of the SQL statement that is using that bind variable to generate the execution plan. Now, the problem is, however, that when you're going to use bind variables, it can be that always using the same execution plan is not always appropriate for all bind values. What it means is that, let's say, the very first time that you execute this select statement, you have set the min_cell variable to 12,000. Now, the very first time that you execute it, the optimizer peeks at the value that you have set for the min_cell bind variable, and based upon that value, in this case 12,000, he's going to calculate selectivity and cardinality and come up with an execution plan. And that execution plan, generated while keeping in mind that min_cell is 12,000, will be stored inside the library cache, in fact. Now, suppose that this execution plan A is a full table scan, in fact. And let's say when you execute that select statement with min_cell 12,000, let's say that you're getting back 40% of your table. Well, having a full table scan to obtain all the jobs where the minimum salary is bigger than 12,000, that's a good execution plan. Now, the second time the statement gets executed, but with a minimum cell of 18,000, he finds an exact match of that statement inside the library cache, and he will use that execution plan that is cached inside the library cache alongside that SQL query text, in fact. So he will be using that same plan, which I've said, let's say it's a full table scan. But let's say that he's using a full table scan to get all the jobs where the minimum salary is bigger than 18,000, and let's say that only 0.5% of the table is being returned, in fact. So performing a full table scan to only return, let's say, 0.5% of the data, that is maybe not a good execution plan. Maybe upon that column there is an index. Well, if only few records are being returned, it's maybe a better idea to use an index instead of a full table scan when looking for minimum salaries that are bigger than 18,000. While with the third execution of that select statement, but with min_cell to 7,500, he will be using that same plan again, because that's the idea of cursor sharing. It's a full table scan, but that select statement, where you look for minimum salary bigger than 7,500, it returns maybe 30% of that table. Returning 30% of a table by means of a full table scan, that is considered being a good execution plan in that case. So you see that you're going to use bind variables to reduce the amount of memory needed to cache SQL statements. You're also going to use bind variables to reduce parsing time, but it can lead to the utilization of a suboptimal execution plan for certain values of that bind variable. So that's something that you will have to keep in mind, in fact. The fourth topic of this chapter discusses how you can influence cursor sharing. Oracle 8i introduced the possibility of sharing SQL statements that differ only in literal values. Oracle 9i extended this feature by limiting it to similar statements instead of forcing it. Similar means that regardless of the literal value, we use the same execution plan. Not similar means that you can have different execution plans for different literal values. How can we influence cursor sharing? Well, you can do that by means of the cursor sharing parameter, which accepts values force and exact, with exact being the default. And that cursor sharing parameter can be changed with an alter system command, or can only be changed for your session, and can also be set in the initialization parameter files, which are being used, for instance, to start up the database environment. You also have the possibility to force exact cursor sharing by means of the cursor sharing exact hint that you can embed within your SQL query. Now, cursor sharing means that you're going to use bind variables. Now, what you will get is that using bind variables to replace literal values within a select statement requires that you have access to the source code of that application that issues those select statements. Now, very often you do not have access to that source code, so there is no way to replace your literal values by means of bind variables, but there is a way to force him to replace literal values by means of bind variables, and that is setting the parameter cursor sharing to force. Let me just show you this via an example. If I go back to my practice machine, you see here, for instance, that I logged in as user HR, in fact. And what I did is I actually emptied my shared pool, which is a memory structure of the instance where the library cache is located. And you see that I have set the parameter cursor sharing to exact. That means that cursors can only be shared if the statements are exactly the same. Now, what do you see here? That I have select star from employees where employee ID equals 100 and it gets executed. Then I execute this statement, but with literal value 101 and it gets executed. Now, this statement is not exactly the same as that statement, where you look for employee ID 100. So cursors cannot be shared. And then I execute a third time almost the same statement, but I'm looking for employee ID 102. Now, these are for Oracle 3 different statements, and those 3 statements will be cached inside the library cache, each with their execution plan, in fact. And you can look up that information because I have a view called VDollar_SQL where I can look up information about my library cache, about the cached SQL statements in the library cache. And I'm asking to tell me what is the SQL ID and what is the hash value of the associated execution plan. And I'm looking for the statements that start with select star from employees. And what do I see is that I have in my library cache, I have those 3 statements, each being cached separately, in fact. But you see that their SQL ID is 3 times different because it's 3 times a different statement. But what do you see is that if you look up the hash values of the associated execution plan, you see that it's 3 times the same thing. So the statements are almost the same, but they are not due to the literal value, but all 3 are using exactly the same execution plan. This is what we call in Oracle terminology unshared SQL. Now, if I want to share those SQLs, I should execute those select statements, not with literal value 100, 101 and 102. Now I replace the coding by bind variables. So I'm going to replace the literal values 100, 101 and 102 by bind variables. Yeah, but that means that I will have to adapt my coding in fact. Now what you can do is you have the possibility to set cursor sharing to false. So look, I'm emptying my share pool to have a clean start, and then I'm putting the cursor sharing parameter to false in fact. And I execute exactly the same statement. So I do not change the so-called application code. So I get all the people where employee ID is 100, where employee ID is 101, and where employee ID equals 102 in fact. Now I look up the SQL statements that start with select staff from employees cached inside the library cache, and also their SQL ID and their plan hash value in fact, what you see is that I only have one time my select statement being cached, but I see that my literal values have been replaced by a system bind variable in fact. And this is what we call cursor sharing in fact, because the statement actually only had to be hard parsed one time, but then it got executed 3 times. So you win memory in the library cache as well as you win time on parsing in fact. So if you do not have access to the source code to replace your literal values with bind variables, you can then influence cursor sharing by setting it to false, so that literal values are being replaced by a system generated bind variable. Now the last topic of this chapter discusses the 11G introduced feature, the so-called adaptive cursor sharing. Now, what is that adaptive cursor sharing? Now, remember that in previous slides, we have said, look, use bind variables because you win time on parsing and you will reduce the amount of memory needed in the library cache to cache SQL statements, in fact. However, if you use bind variables, you will always use the same execution plan for each bind variable value. Yeah, but for certain bind variable values, this can lead to the utilization of a suboptimal execution plan, in fact. So you use bind variables to win parse time and to win memory, but you know in the back of your mind that for certain values of the bind variable, reusing always that same execution plan can lead to the utilization of a suboptimal execution plan. Now in 11G they introduced adaptive cursor sharing. This means that you want to have the best of both worlds. So you want to use bind variables in order to reduce memory utilization and to reduce parse time, but we also want to make sure that for certain bind variable values that we're not always using the same plan for each execution, in fact. So it's intelligent cursor sharing for statements that use bind variables. So it's a compromise or use the best of both worlds between cursor sharing, win memory, win parse time, and using always the best execution plan if you use different bind variable values, in fact. It has the following benefits. It automatically detects when different executions would benefit from different execution plans. It limits the number of generated child cursors to a minimum. And it's an automated mechanism which simply cannot be turned off, in fact. Now, before I will show you the rest of the slides concerning adaptive sharing, let me first show you a demo that you see it in action, this so-called adaptive cursor sharing. So let's go back to my practice machine. And what do I have is here. I created a table emp. It has 4 columns, emp_no, ename, phone, and depno. Now in my story, it's a depno column that plays a crucial role, in fact. And I create an index upon the column depno of my table emp. Then what did I do is, via PL SQL block, I have inserted 99,900 records in my table emp, where the department number equals 10. I have 20 times a record inserted where department number is 9, and I have 700 times a record being inserted where department number ranges from 1 to 700. Now, what do I have in my table? That in my table, I have a lot more records where department number is 10 than I have records where department number is 9, in fact. So you can see that here. When I'm selecting the count from emp where depno is 10, you see that there are 99,901 records in my table emp where depno equals 10, while there are only 21 records where department number is 9, in fact. So you can already see that I have so-called skew distribution of data inside my department number column. There are more records where department is 10, then I have records where department is 9, in fact. Now, if you suspect skew distribution in a column, ask to calculate a histogram, in fact. And that's what I've done is, by using the procedure gather table stats of the package dbms stats, I have asked to create an histogram on the column depno of table emp of schema HR, in fact. And you can see that in user tab calls, I can see that upon department number, an histogram, in this case a height balanced histogram, has been created, in fact. Now look, what I've done then is, I have here a bind variable, so a host variable that I've declared in my session, and I give it the value of 9. And I'm going to execute this select statement, where I'm reading upon table emp where depno equals the value of that bind variable. Now, this is the very first time that I'm executing that statement. So hard parsing is going to take place. Plus also, the optimizer is going to perform bind peaking, is going to have a look when building up the execution plan. But what is the value that you use for depno? Oh, it's 9. And based upon that value, he's going to calculate selectivity and cardinality, and in the end come up with a specific execution plan, of which you hope this is the optimal execution plan, in fact. Now, just for the record, this is not a hint. This is simply a comment that I've set in my query, so I can easily find back the information about that query. So this is, to be clear, not a hint being used. And look, I'm saying there are 21 records where department number equals 9. Now, if I'm going to have a look at, but what is the execution plan that you have used to execute that statement, of which the execution plan was built based upon value 9, in fact, well, it says I'm using an index. Now, look, I'm very happy with this, because on a table that holds about 100,000 records, it only retrieves 21 records by making use of an index range scan, in fact. This is a really good execution plan, in fact. 100,000 records, only returning 21 records, and you obtain that via an index. That is a defendable scenario, in fact. Now, what I'm going to do is look, if I take a look in SQL, and I'm looking up information about the select statement with the command ACS_1, well, I see that there is one version of that statement. It has been executed one time, and in total 11 blocks have been accessed, in fact. It's bind sensitive, because you have been using a bind variable, but it's not yet bind aware. This is important for the so-called adaptive cursor sharing, in fact. Now, what I do now is, within my session, I put the bind variable depno to 10, and I'm going to execute this select statement again. So you see here, select the count max empno, but for the records where depno equals 10, in fact. Now, what happens is, this is the second execution, he will find an exact match inside the shared pool, in fact, inside the library cache of the shared pool, because of the execution with bind variable value equal to 9, in fact. So he finds the exact match, he finds the execution plan and he will use that execution plan that he used when he was searching for the records where depno equals 9, in fact. Now what you're seeing is, he's using the index scan, in fact. Yeah, but in my table there are about 100,000 records, but he returned 99,900 records. So 99% of the table was returned to the application, but it means that 99% of the data was selected due to an index range scan. Now returning 99% of a table via an index, well, that's not really a good idea. You probably are better off with simply doing a full table scan. But that's a problem that you have with cursor sharing, that for certain values of bind variables, it can lead to the utilization of a suboptimal execution plan, in fact. Well, what you're getting now is this. So you see, if I look into my library cache, I still have only one version of that select statement. It has already been executed twice, one time with bind variable 9, one time with bind variable 10. And in total, for do execution, already 652 blocks have been accessed to obtain the results of both execution, in fact. But now what you're getting is this, is the following. I'm going to execute, so my bind variable is still 10, but now I'm going to execute it again. So I'm looking again for those records in table emp where depno equals 10, in fact. I'm still getting back 99% of that table. And if I look at what is the execution plan that you have chosen, he says, yeah, but now I'm using a full table scan, in fact. Although that statement is found in the shared pool with execution plan using an index, for that third execution, he's now using a full table scan, which is a much better idea than an index range scan. Now, actually what has happened is, during the second execution of that statement, so the very first time that my bind variable was equal to 10, he executed it with the execution plan found in the library cache, so with the index range scan. But what he then does is, he also captures the execution statistics of the execution of that statement with bind variable value equal to 10, in fact. If then the third time you're going to execute that statement again with value 10, the optimizer says, yeah, but wait 1 minute. I have previous runs of this select statement, so he finds an exact match in the library cache, but I have also captured the execution statistics of the previous runs of that statement. I have the execution statistics of the execution with bind variable value 9 and with bind variable value 10. And what he does is from the third execution is going to compare the estimates that he has made. He's going to compare that with the execution statistics of various runs. And he sees, yeah, but with department number 10, if I look at the execution statistics of the previous run, with the estimates that I have made to build up the execution plan, which is the index range scan, I see that there is actually a big discrepancy between the actual number of rows being returned and the estimated number of rows. Well, at that moment in time, the optimizer says, look, I don't think using the previous index range scan execution plan is a good idea if you're using bind variable depno with value 10, and it's going to see if he cannot find a better execution plan, in fact, which is in this case then the full table scan, in fact. And you will see that your select statement has now a new version inside the library cache. It was executed one time, and you see with the third execution of that statement where department number bind variable is equal to 10, he only had to read 345 blocks to obtain the results instead of the more than 600 blocks that he has read before. And this version of that statement is actually generated due to the adaptive cursor sharing. That is, that column is bind aware. If I then execute with department number 9 again, he's using the index range scan, in fact, creating a new version because that's also a version that was generated due to this adaptive cursor sharing, in fact. And you have the possibility to look. You see that I have child number 1 and child number 2, but it's exactly the same statement, in fact, but with a different execution plan. You have the possibility by means of certain $v views for the different version of that SQL statement to look at, but what was the calculated selectivity for that child version of the statement, and you see that there's a totally different selectivity calculation for child number 1, in fact. But that's your adaptive cursor sharing. It's an automatic feature, and that's especially being used or goes in effect for columns that are used in combination with bind variables, and upon those columns, histograms have been calculated, in fact. So that is your adaptive cursor sharing, in fact. So I've shown you a demo so that you have an idea how this actually works, in fact. So what's happening is the very first time that you execute this select statement is going to, based upon the values of both bind variables, that's the bind peaking, is going to calculate the selectivity. So it's going to make an estimation of the number of records that he thinks are going to be retrieved, and based upon that he's coming up with an initial plan, and that gets stored inside the shared pool. The second time it gets executed, he will find an exact match, and he's going to use exactly the same execution plan, in fact, but he will collect execution statistics of that run, in fact. From the third execution on, before he says I have found a statement and I found an execution plan, he's going to compare execution statistics of previous runs with the estimates that he has made, and if there is a big discrepancy between the estimation and the actual execution statistics, in fact, he's going to see if he cannot find a better execution plan, in fact. And that's something that he will do every time that you're now going to execute that same statement with the same bind variables but with different values. Always look at the execution of previous executions, compare that with the estimates. If he says, look, I have an execution plan with that estimates compared with those execution statistics, you can use that execution plan, or if needed, I can see if I cannot find a better execution plan for those values of the bind variables for this execution, in fact. That's a little bit your architecture, in fact. There are several views to obtain information about adaptive cursor sharing utilization, in fact. So in the VLOR SQL, you have two new columns where you can see if the cursor is bind sensitive or it's bind aware, in fact. Plus you have views like VLOR SQL, cursor sharing histogram, cursor sharing selectivity, and cursor sharing statistics, where you can find more information about the adaptive cursor sharing. You have here an example on the slide where they tried to explain the adaptive cursor sharing, but that's actually being explained by me with my own demo, in fact. Now, if your cursor sharing is different from exact, statements containing literals may be rewritten by using bind variables, and statements that are using bind variables, adaptive cursor sharing may apply to them, in fact. If you're using SQL plan management, so if optimizer capture SQL plan baselines is set to true, only the first generated plan will be used. You can put it to false, run your application to load all the plans into the cursor cache, in fact, or you can also manually load the cursor cache into the corresponding plan baseline. This SQL plan management is something that is explained in chapter number 12 of this course. Now there are 2 or 3 quizzes in this chapter to end this chapter. So which 3 statements are true about applications that are coded with literals rather than bind variables in the SQL statements? Is that A, more shared pool space is required for cursors, less shared pool space is required. Histograms are used if they are available, in fact. Histograms are not used. there is no parsing required for literal values, or every different literal value requires parsing. So which three statements are true? The three statements that are true is statement A is true. More shared pool space is required for cursors. No. Histograms, no, are being used if they are available, in fact. And every different literal value requires parsing. That is if you code with literals instead of bind variables. The cursor sharing parameter should be set to a force exact literal true or false for systems with large tables and long-running queries such as a data warehouse, in fact. The right answer is here, it should be set to exact. So answer B is the correct answer. Adaptive cursor sharing can be turned off by setting the cursor sharing parameter to false. This is not true, this is false, because adaptive cursor sharing is an automatic feature. Now in this lesson, you have learned how to list the benefits of using bind variables, use bind peaking, use adaptive cursor sharing, and describe some common observations. You can now complete some exercises for this chapter number 11. The practices cover the following topics: how to use adaptive cursor sharing and bind peaking, and how to use the cursor sharing initialization parameter. Practices for lesson 11 using bind variables. In the practice of chapter number 11, you examine the behavior of adaptive cursor sharing and the effect of various settings of the cursor sharing parameter on execution plans. In the first activity of this chapter, you will experiment with bind variable peaking and adaptive cursor sharing. The ACS setup shell script was executed as part of the class setup to set up the environment used for this practice. All the necessary scripts for this activity can be found underneath the adaptive cursor sharing directory. So if you want to reinitialize your environment for this first activity of chapter number 11, the only thing that you need to do is you have to switch to the directory adaptive cursor sharing and launch the shell script acs_setup.sh. This will set up a connection to ORCL PDB, creates a user ACS, will grant the necessary roles, and then in that schema of ACS, a table emp is going to be created and records will be inserted into that table emp. Also, histograms will be collected upon the column depth of that table emp, and also the shared pool is going to be flushed. Column depth also has an index built upon it. Then what you're going to do is you're going to establish a session as user ACS and flush the shared pool. And you're going to check which columns of table emp have histograms. You would see that only the department number column has a 10 bucket histogram. So I have here a terminal. Let's switch to the adaptive cursor sharing parameter. And then I establish a session as user ACS upon the pluggable database ORCL PDB. I'm going to flush the shared pool. And then I need to launch the script check emp histogram to verify which columns have histograms. I'm going to state here check emp histogram. And what do I see is that there are 4 columns in table emp, but that only the department number column has a 10 bucket histogram. Then we're going to have a look at the distribution of the distinct values in that department number column of table emp. So you're simply going to run this script. Just one moment. Going to run that script. And what do I see is I have 11 distinct department numbers. Now most department numbers show uniform distribution, except department number 10 pops up in 99.9% of the data. This is a typical cause of what is called data skewness. So there are not that many records with department 9. There are a lot of records where department number equals 10. Then before you're going to study the adaptive cursor sharing feature, we're going to disable that functionality. And that is by setting the optimizer features enable parameter to 10.2, because adaptive cursor sharing is a feature that was introduced as of Oracle 11G. So I'm going to copy this command and I'm going to put the optimizer features enable parameter to 10.2. Then for the sake of showing the execution plan in a correct way, we're going to set the line size to 200 and the page size to 10,000. Then what you need to do is you will have to determine the execution plan for the following statement. So I'm going to read my table emp and search for those records where department number equals 9, of which we know that that value 9 doesn't appear that much inside that department number column. So you can simply run this script file to execute that select statement. I'm going to run this. You see only 10 records have a department number equal to 9. Then we're going to use this script to show the execution plan of the latest executed SQL statement. So if I do so, I'm seeing that the optimizer has chosen to use the index upon that column depth. Using the index to retrieve only 0.01% of the data out of my table is probably the most efficient way to carry out that select statement. Then we're going to determine the execution plan for this statement. It's exactly the same statement as before, except that the literal value has changed to 10. So it's not the same statement as we have run before. So what we're going to do is going to run the script select depth no literal 10 to execute that select statement. You see that 99,900 records have been retrieved out of a table that has 100,000 records. And if I then going to look at what is the execution plan that was used to carry out that last executed statement, I'm seeing that he has chosen a full table scan, which is a very good execution plan, because value 10 is not a selective value because it appears in 99.9% of the records of this table emp. Now what we're going to do now is that we're going to execute that same statement again, but we're going to make use of a bind variable called depno. The statement itself is found in the script select depno bind.sql. But first you have to declare a bind variable with the name depno. So use the SQL plus command variable. And then you're going to execute this command to set the bind variable value equal to 9. So if I show you var depno, you see that the value, so the data type is number, and if I print depno, you see that its value for my session is equal to 9. And then I'm going to execute that script file that execute that select statement using that bind variable. So I'm getting my results, and then I'm going to have a look at what was the execution plan that the optimizer has used for that select statement using a bind variable. I have to copy paste. Now what do I see is that he has chosen an index range. Now this is the very first time that this statement was executed with that bind variable. For the first execution of that statement with a bind variable, the optimizer is going to have a look in order to build up the execution plan. Is going to have a look, yeah, but what is the value of that bind variable for the session for which I'm about to execute that statement and build up an execution plan. And it's using that value of 9 to decide upon the execution plan. And he comes up, I think that we're better off with an index range scan, which is a very good idea because once again, by an index retrieving 0.01% of the data is probably the most efficient way to do so. But you see that he has done bind variable peaking. We're also going to have a look at the execution statistics of that statement by running this script file. So what you get is that if I execute this, what do you see is that that statement has been executed one time and that in total only 3 blocks have been accessed. So you have only one child cursor for that SQL statement. It has been executed once, the first time ever in this case, plus also the number of buffer gets is small due to the efficient access path that was used. Then we're going to do exactly the same thing as before, but we're going to put the bind variable equal to 10. We have seen that using a full table scan is the most efficient way to do so. Yeah, but let's see how it behaves with a bind variable. So what I'm going to do is I'm going to say execute, and I'm putting the bind variable depno equal to 10. So you see now with the print command that the bind variable value for my session has value 10. And then I'm going to execute that select statement again. That is using that bind variable. 99.9% of the table has been retrieved. Then I need to show, yeah, what was then that execution plan that it has used for that statement with bind variable value equal to 10. Well, if I do so, what do I see is that he's also using an index range scan to look up all the records where department number equals 10. But why did he choose the index range scan? Because this execution plan was stored inside the shared pool with the first execution of that statement when department number was equal to 9. Then I've put my bind variable to 10 and I re-executed that same select statement. Well, he finds an exact match inside the shared pool. Well, he will pick up the associated execution plan, which was in this case an index range scan, and is going to use that to retrieve all the records where department number is equal to 10. Yeah, but this is the utilization of a very inefficient access path to retrieve 99.9% of the data. And you can also see that this bind variable peaking only happens at the first execution of that statement when using a bind variable. With the second execution, he still thinks that his department number is still equal to 9, although for my session, and he's not having a look at it, although for my session that value has been set to 10. And then I'm going to have a look at the latest execution statistics. Now what do I see is that I have 2 executions of the same statement, but you see a tremendous increase in the number of buffer gets because it's scanning the index and then also returning 99.9% of the data out of that table. Now, for the next observation, we first have to flush the shared pool. So we're going to empty this shared pool. It's now empty. I'm seeing that my bind variable depNo is still set to 10. If not, I can set it to 10 via this command. And I'm going to execute that select statement. Now, it's no longer found inside the shared pool because I have flushed it in the previous step. So if I execute this, it's executed. And if then I'm going to show the execution plan of the latest executed SQL statement, what I see is that he's doing a full table scan. But what he did is, this is the very first time that that statement was executed after I flushed my shared pool. He did the bind peeking to my variable depNo. The optimizer saw that it's 10. Based upon that value 10, he calculates selectivity and cardinality, and he says, I think the most efficient way is to perform a full table scan. And let's have a look at the execution statistics. I have one version, one execution, 956 buffer gets. Now we have to do exactly the same thing again, but with the bind variable depNo set to value number 9. So I'm going to put the bind variable equal to 9. I'm going to execute that statement again. So it's using that literal value, but with the bind variable value equal to 9. And then I'm going to have a look what was that execution plan. And what do I see is that is using a full table scan because this is the second time that I'm executing that statement. It is found inside the shared pool. It simply picks up the associated execution plan and does a full table scan. He doesn't do the bind variable peeking, so he's not having a look what is the value of that variable at this moment. He still thinks that it's a value 10, and he has found the execution plan already inside the shared pool. Now, using a full table scan to only retrieve 0.01% out of a table is probably not the most efficient way to do this. The index range scan is the most efficient way. This is a disadvantage that you can have when working with bind variables. If I then take a look at the latest execution statistics, you see that now it was a second full table scan. 1761 blocks have now already been accessed after 2 executions of that statement. Now what we're going to do now is we're going to have a look at adaptive cursor sharing. Now we have to reactivate this, and what we will need to do is we will have to set the optimizer features enable back to 11 or 12 or higher to enable adaptive cursor sharing. And we're also going to flush the shared pool so that we always have a clean start for our observation. Then what we're going to do is we're going to do exactly the same thing again as before, but with bind variable depNo equals to 9. So I'm simply going to check, in my session, bind variable depNo, it's still 9. If not, via this command you can put it to 9. And now you're going to execute that same select statement again with that bind variable. This is the very first time that I'm executing it after I flush the shared pool, so bind peeking will be used. So if I'm going to execute this, I'm going to show the latest execution plan. Because value 9 is selective, it's being picked up by the optimizer. Based upon that calculate selectivity and cardinality, the optimizer says, let's go for the index range scan. And let's look at the execution statistics. You see that one execution of that statement, 151 blocks have been accessed. Then we're going to do exactly the same thing again, but we're going to put the bind variable equal to 10. So I'm going to state execute that no, putting the value equal to 10, and I'm going to re-execute that statement by launching this script file. So I'm retrieving 99.9% of the data out of my table. And let's have a look at the execution plan that has been used. And what do you see is that he's using an index range scan. Now, what you will have is, although value 10 is not selective, the same index path as in the previous step is being used. So he finds an exact match, going to pick up the execution plan of the shared pool of that statement, which is an index range scan, and is going to use that, which is, we know, is not the most efficient way to retrieve all of the data out of my table where the department number equals to 10. And let's have a look at the execution statistics. You see 2 executions, 1105 buffer gets that have been done. But then we're going to do again the same statement with bind variable equal to 10. So I'm checking department number bind variable is still 10, and I'm going to execute that statement once again, like this. And let us have a look at the execution plan that has been used. And what do I see is that he's now using a full table scan. Now this is an example of adaptive cursor sharing, because the system has realized that you would benefit from another child cursor for handling your statement. He saw with the second execution of that statement with bind variable depth node 10, he saw that the actual execution statistics has shown a big discrepancy with his estimates, and it says when you execute that statement again with the bind variable value depth node equal to 10, I'm going to check if we cannot find a better execution plan, and in this case he came up with a full table scan. And let's have a look at the execution statistics. You will see that you have now 2 versions of that same statement, each using a different execution plan. You simply have to flush the shared pool again, and you're going to exit the SQL Plus session. And we exit the SQL Plus session. In the second activity of chapter number 11, you investigate the utilization of the cursor sharing initialization parameter. All necessary scripts are found underneath the directory cursor sharing. Now the environment for this practice has already been set up with the class setup. However, if you want to reinitialize your environment for this specific activity, you can simply launch the shell script cs_setup. So if you want to do this, you make sure that you switch your directory to cursor sharing. You launch the shell script cs_setup, and this will create a user CS, grant the necessary roles to CS for this practice, and then in the schema of CS is going to create a table emp. It's going to insert data into that table emp, creates an index upon the department number column of the emp table, and gathers optimizer statistics upon that table emp. Once you have done this, you're going to establish a SQL Plus session as the CS user, and you will stay connected to that session until the end of the practice. And you're also going to set the line size and the page size in order to have a correct display of the execution plans later on in the practice. So here I switched my directory to cursor sharing, established the connection as the CS user, and set the line size and the page size setting in my SQL Plus session. Then what we're going to do is we're going to check if there are histograms upon the columns of that table emp by launching this script file. What do I see is that there are no histograms built upon the columns of my table emp. And we're also going to have a look at the data distribution inside that department numbers column by executing the script show depno distribution. Now what do I see is that there are 11 distinct values in the department number. Most department number values show uniform distribution, except department number value 10 appears 99.9% of the time in the rows of this table. This is a typical case of data skewness. Then we're going to, for this activity, flush the shared pool to have a clean start for the observations. Then what we're going to do is we're going to set the parameter cursor sharing to force to automatically replace statement literals with bind variables to make sure that the same cursor is used independent of the literal values. So via this command we put the cursor sharing parameter to force. And then what we're going to do is we need to launch those two select statements which are both using a different literal value, making them different statements. Now, what we're going to do is to execute this select statement, we have to run this script file, while to run that statement, we have to run this script file. So what I'm going to do is I'm going to execute this statement with literal value 9. And then I'm going to execute the script literal 10 to execute the same statement but with literal value equals to 10. Now we will see, because of the previous step of setting cursor sharing to force, literal values are being replaced with bind variables. The force option forces Oracle to share only one child cursor in this case and use the exact same execution plan. So let's have a look at the latest cursors that have been placed inside the shared pool. You use the script show latest cursors. Now what do I see is that I do not find the statement where the literal is 9 and I do not find the statement where literal is 10, but I will find the statement where the literal values have been replaced by a system bind variable. We can also have a look at the latest execution plans by running show latest execution plan script. And what do I see is that there is one execution plan inside the cache, and that execution plan is using an index range scan using the index emp I1 upon table emp for that particular select statement that we have done over here. Now what we're going to do now is we're now going to create an histogram upon column depno of table emp. We're creating a histogram upon that column because we have seen that there is data skewness in the data distribution of my depno column. Now, by calling together table stats procedure of the package dbms stats, I can ask to collect histograms upon column depno with a size of 10 buckets. So what you need to do is going to copy paste this command. I execute this, and an histogram will be calculated upon that column depno. Then I'm going to see if the histogram was created. And what do I see is that there is now indeed a histogram with 10 buckets upon this column depth node of my table emp. Then I'm going to empty my shared pool again to have a clean start for the observations. So I'm emptying the shared pool. And then what I need to do is I have to rerun those two statements using a different literal value. So I'm going to execute this script. Plus I'm going to execute the script literal _10, knowing that the cursor sharing parameter is still set to false. We're going to have a look at what are the latest cursors being created inside my shared pool. And what do I see is that I only have one cursor, in fact, because the cursor sharing parameter is set to false. So literal values like this 9 and this 10 are being replaced by a system bind variable. Plus also what you will get is, although that there is a captured histogram for the department number column that shows data skewness, the system will continue to share only one child cursor to handle both statements. This behavior is due to the fact that the cursor sharing parameter has been set to false. At the end, you have to flush the shared pool again and exit your SQL Plus session.